right, with that, we're live on air. Thanks everyone for tuning in to another episode of Fermyon Live. This is a special one. First of all, I'm not alone on stream, so with me is Matt. Matt, you want to quickly
Yeah,
introduce yourself?
I'm Matt Butcher. I'm the CEO of Fermyon. Was at Microsoft when we kind of caught that vision that led us to starting this company and doing the WebAssembly thing here. Super excited to be here today, although I'm struggling really with FOMO today, and you can probably tell us why.
Yeah, I'm not within my usual room. I'm actually in Barcelona for WebAssembly, which is taking place today and tomorrow.
And I am in my usual room. This is the first time I have ever missed WasmIO. It's by far just one of those fantastic conferences, probably the best WebAssembly conference, one of my favorite developer conferences, because there's the breadth of what they cover there. There's so many different things that touch WebAssembly that you hear from everyone from like people who are writing compilers to people who are compiling Doom and running it in the web browser to people who are doing interesting things in the AI and serverless and embedded space. It's just like you get a sampling of all these really cool, innovative areas that are happening in technology, all of which kind of run adjacent to or touch on WebAssembly. So this is like FOMO Thursday for me. In fact, I kind of want to know, what's the vibe? What's it like this year? It's always such a positive conference. Oh, I know what so this is the one conference I've ever been to where they always open with a local musical guest. Did they do that this time? What was it?
It was not a music like show. It was more an artist. Basically, they had like 12 or 16 cubes, like 40 by 40 centimeters each, and he was randomly drawing like lines on different cubes, right? And once he was done, he rearranged the cubes with the WasmIO logo and Barcelona 2025 as a tagline under it. So that was super great. So he kept on, saying nothing and just painting for 5 minutes, and you saw that progressing to become the WasmIO logo. That was awesome.
That's awesome. So it's kind of like performance art and then do they have like a musical background or something, or was everybody just standing there in the quiet, in the silence?
No, they had obviously some background music going on, but then he did a great performance, right? He looked at his like thing in the first place, so a little bit puzzled, so he looked like questioning to the audience, and he made everybody clap, and while more and more people start clapping, he started rearranging the cubes and building the logo. So that was awesome. I mean, that's Sergey and his team, they do like a fantastic job right now for 3 years in a row.
Yeah. And I really I think it's good to have the artistic element present in any developer conference, because it reminds us that a big part of our job is actually creative. I think engineers start to get into that theory that we're pure rational actors, but this is one of the most creative disciplines that you have, right? It's a matter of going from nothing to try and expressing very complex things in a way that both humans and computers can understand. And I love the fact that Sergey kind of always incorporates that creative element right up front. How about the general vibe? What's it like there?
It is like, as you mentioned, it's pretty similar to me, right? It's like the conference of the year, right? It's community-driven conference. Sergey mentioned in the keynote that there were attendees from 29 countries, which is massive, especially if you are considering that it's back to back with KubeCon U, one of the biggest like tech conferences in Europe, happening next week, right? Which puts a lot of pressure on those developers that want to visit both and may have family duties and stuff like that. But still, I mean, there are more than 160 attendees, a lot of familiar faces, a lot of new faces. So I think I was up this morning at 6 a.m. and was pulled into conversations, at breakfast about WASM, and that just kept going up until I said, "Hey, I have to hide in the hotel room for going live."
No, so that's right, because You did your presentation this morning with Karthik, right?
Yeah.
Some spoilers and tell us what that was about.
Yeah. So Karthik and I, we were we were doing the second talk after the keynote, right? And we were basically explaining component composition using latest and greatest tools provided by the Bytecode Alliance and the WebAssembly community, how that works, walk the audience through a demo of doing that composition the manual way. And then we showed a more elegant or an alternative approach by basically showing them the Spin Depths plugin, which is an experimental plugin we created that streamlines the entire DX, so the developer experience of doing that composition. So it takes away a lot of the, like pain points, like running all those commands in the precise order, factoring in language specific tooling. And as always, we try to keep it language agnostic so that, it doesn't matter if you're a JavaScript, TypeScript dev, if you're a Rust dev, you just use those single line command and it takes care about the heavy lifting under the covers. So that was basically our talk, and it went super well. We tried to engage the audience, had some nice pictures of Barcelona in the slide deck, of Radu staying on stage doing the keynote for the first iteration of WebAssembly. So
yeah,
it was great.
I think one of my all-time favorite conference presentations is actually the one you gave last year at WebAssembly. So I'll have to watch this one when the video comes out. But I think it was last year where you had different hats for which programming language you were using. And you were, wearing a blue hat, doing some Python, then you take it off and put on an orange hat with the JavaScript logo on it. And I think you turned it around backward to do TypeScript or something like that. I mean, the theme running between the two, I suppose, is just that, with the WebAssembly component model, being able to begin building polyglot applications where you pull in a library written in Rust into your JavaScript program, build a library there, pull it in from a Python. And I think that a lot of this tooling that has been happening both in Bytecode Alliance and with Fermyon and the Spin tooling has been designed to make that story easier and easier, because it feels daunting to start out and with the component model itself, right? It's a complex specification. To have tooling that can just do stuff for you and get you going in seconds instead of in 20 minutes even is just phenomenal.
Yeah, you're absolutely right. So last year I was the intention of my talk last year was to approach it from an application developer's point of view of how far could I, taking that position, push the boundaries and build something with components. And there was a lot like, preparation going into that in order to align all the tools and make them work together. So 1 year later, like the entire ecosystem has evolved and graduated that much that all the tooling that is available is great, but you have to, know which knobs you have to turn at what point in time. And with Spin Depths, as you mentioned, we always try to, improve the DX, go down to seconds instead of minutes, and to basically make everybody's life easier, and so that we can focus, or all developers could focus on solving requirements instead of, tackling technology problems, right?
Yeah. And I think last year, so you did the developer-oriented one on components. Ryan Levick did one that was sort of like the history of components and why it worked the way it did, and sort of a little bit of a peel back one layer of the surface. And Luke Wagner did this sort of where components are going presentation last year. And the three of you hadn't planned doing that kind of triumvirate of it. It just kind of worked out that way. Did Luke do his session today? Has Luke done his yet?
Luke,
by the way, for those of you who are not familiar, Luke was the creator of WebAssembly and has, wrote this blog post in 2015, sort of announcing WebAssembly to the world. He's been highly involved. He works at Fastly, has worked on the WebAssembly system interface and the component model most recently, and is a fantastic human being. In addition to all of that, I really like him.
Yeah, the fun fact about last year's schedule was that it was as you mentioned, it was not planned. It was not planned in the way that we have, like, I did like the level 100, Ryan did level 200, and Luke did level 300,
Yeah, that was
going
very
all
much the
out.
feel.
Yeah, and I think they were like pretty much in order. And so Ryan was sitting in my audience and adding a slide to his talk, basically giving the people, giving the audience, right, that, okay, Torsten did the 100, Luke is going to do the 300, let me be in the middle and let me do the level 200. Yeah, that was great. And yeah, so Luke, coming back to your question, Luke did a talk as well today on async and threading, obviously. Show latest happenings in that area, in WASI, and yeah, so a lot of great talks. However, I wasn't able to watch that many talks. I got pulled into conversations. So we have a booth, as you may know, we have a booth there, right? So we got pulled into a lot of conversations because I think we had also like a short appearance in the keynote.
Yeah. I think Radu did his now famous 2-minute keynote at the beginning, right? I think he's done a 2-minute keynote on every one of these. So we should go ahead and spoil it. What was the big news today?
Surprise, surprise. So I think first and foremost, he mentioned that Spin and SpinCube are officially CNCF sandbox projects. So that was the first cheering moment. But I want to hand it over to you to basically rephrase what Radu mentioned earlier today.
So today we launched Fermyon WASM functions with Akamai. And so, well, actually, let me just tell the story, right? We have been passionate since the very beginning that we wanted to build a runtime for serverless functions that was just like mind-bogglingly fast, right? We wanted to just blow the doors off of the performance we were seeing from Lambda, which has 200 to 500 millisecond cold start, or Azure Functions, which has something similar. And so when Fermyon got started in 2021, the first project Radu really kicked off was Spin, a developer tool that built these kinds of applications, built on top of Wasm time, and then from there we started adding more to this vision. Right, first thing you got to do is build a developer tool. Next thing you got to do is sort of give people a place to run it. With many of us being sort of long-time cloud native / Kubernetes developers, it made sense for us to build a WebAssembly runtime inside of Kubernetes. And we got a surprising announcement about that today too. But then what we discovered was, regardless of how fast you make the runtime, network latency is gonna present problems, right? So even if you can get it down to a 0.5 millisecond cold start time, which is effectively where we are, if you're sitting on the other end of a network link that takes 100 or 120 milliseconds to deliver from some data center in California to wherever you are, then you haven't really solved the problem in a satisfactory way, right? What we learned kind of along the way, Google did some research several years ago and said that if people load a web page and don't start to see something happening within 100 milliseconds, their attention begins to drift, and you start to see percentages of users falling off at 100 milliseconds. 100 milliseconds, by the way, is how long it takes you to blink your eye. So literally, you have the blink of an eye to get information displaying in front of a user. And we had gotten so passionate about this compute part that we essentially hit our goals and then went, well, wait a minute, we still can't quite do the blink of an eye thing. And that's when we started talking with Akamai. Akamai has the biggest distributed compute network in the world by a long shot, right? It's just this huge, massive points of presence all over the place. They acquired Linode a couple of years ago, which gave them a really heavy duty compute platform that we could build on for sort of like the control plane. And they just started rolling out this new compute style called the Global Edge Compute, Gecko, system, and these are some really powerful compute nodes, many of which have GPUs available on them. So we're really excited because they were basically building the foundation for all the networking stuff that we could just drop a compute layer on top of and build this really cool system. So today the big announcement is Fermyon Wasm Functions on Akamai is this new platform. It's Wasm Functions, same things you build with Spin, same things you can run in SpinCube, but now you can push them out into the Akamai network and run them as close to users as possible. Radu has been obsessing over performance numbers, and so from his home in Belgium, he's been testing against our data center in Paris and just pulling absolutely mind-boggling numbers.
He is performance testing from airplanes. He is performance testing from the hotel in Barcelona. So Radu prepared
can't do anything without Radu pulling out a laptop and running a performance test.
his slide was basically showing the histogram and metrics from the load test of a function, right? Yeah. It is.
And it's really exciting because now we're seeing round trips in, some of Radu's metrics have been round trips as low as 13 milliseconds, hovering in the 30 milliseconds range. I mean, it all depends really. And the funny thing about this is at this point, Fermyon and Akamai together are competing against the laws of physics. I mean, that's essentially where we're at now. How close can we get it? How few hops can we get it on the network? How quickly can we get the bytecode executing? And it's just us versus physics at this point.
Yeah, it is. It is super amazing. Yeah.
Yeah. So that was the big announcement today. Torsten just popped a link up there that you can go check out the big announcement. There have been a number of articles in the press today about it. It's all very, very exciting. In fact, in a couple minutes, we should come back and do some demos of that. But before that, sort of a number of other announcements are sort of rolling out today as well. Of course, it's Wasm.io today and tomorrow, but also KubeCon next week, which means all the announcements start to roll out a little bit early because we know that once KubeCon is going, we're all just saturated with information. So today, Akamai also announced AI inferencing at the edge. They now have GPUs available in edge locations. Among that, in that announcement, you will see that Fermyon also, we did serverless AI a couple of years ago. We just kind of kept building on the building blocks we had created back then in order to integrate into Akamai's new offerings. So I think actually, Torsten, we definitely shouldn't spoil this one ahead of time, but the KubeCon booth and the NAB show, we'll be showing some of the demos you wrote that make use of a lot of that. But Akamai also announced today that they are going to be talking about their new enterprise grade Kubernetes edge. I think they're calling it edge enabled or edge ready Kubernetes at KubeCon. So the press release said today, Torsten. I read the marketing material, Torsten reads the tech material, and somewhere in the middle we figure out but then again, Fermyon platform for Kubernetes runs in this environment. SpinCube, the open source CNCF project, runs in this environment. So lots of stuff between Akamai and Fermyon. We're really excited about all of that. And then Microsoft there's an article about Microsoft and AKS today. The AKS is the first Kubernetes distribution that actually shipped with WebAssembly support. And they did this years ago, wrote a shim so you could run Spin applications and other kinds of applications. They just announced that they have deprecated the old version and that now SpinCube is sort of the way to go to run WebAssembly applications inside of AKS. I know they've been working with some of their customers to build and deploy WebAssembly applications inside of AKS. So there's a really good article on that today. I'll have to look up the URL and drop that in the notes as well. But all kinds of stuff going on today. It's been sort of like I woke up this morning, opened my Slack, and was like, "Whoa, what's going on?" There's announcements all over the place. So it's been a good day for us so far with Wasm.io, with some press releases, with some media coverage, and with us finally. You know what the hardest thing about all this is to not talk publicly about the thing you're most excited about. And we've been working on this for the last few months. Now we can finally talk about it.
Yeah, but still, I think the deprecation of Azure's, I think they were called WASI node pools, and moving on and saying, or betting on Spin and SpinCube as their story for bringing WebAssembly workloads to like that vast number of AKS customers that they have is awesome, right? And there's, I know a couple of Fermyon and Microsoft employees worked like quite amount of time on giving like Azure users a great experience by bringing SpinCube to the Azure marketplace, so that you can just try it out by checking a box and pressing the install button. Things that cloud ops don't want us to do, but for development cluster you can just click it in the UI like the next finish wizard. Which is great for exploring SpinCube. And with WASM functions, which we released as of today, you can take the same spinner and just deploy it there, right?
Yeah. And that's a big story. And I mean, this is part of why WebAssembly is such a cool technology, right? Is that you compile it once. Thanks to the component model, it's got this nice abstraction model that away from the runtime, so that you can really write the application, compile it, and then distribute it to lots of different kinds of runtimes that include, running it locally, running it, in embedded systems, running it inside of a Kubernetes cluster like AKS, or running it now on the edge. And that same application can behave the same way in all those different environments. And it's great to be able to do things like, you can even split applications into pieces and be able to build one application, deploy a piece of it internally to your, VPC Kubernetes cluster, and a piece of it out to the Akamai edge now. I mean, it's just very exciting that WebAssembly is really starting to show its versatility way beyond the browser, right? Like all over the place. But in particular, we're just loving the fact that this vision of building a serverless application platform like Spin, where you're literally just writing event handlers and then be able to run those same snippets of code in all these different places to enable developers to build really powerful and very, very fast applications. It's just been a really exciting day to start to see one more piece of that vision sort of fall into place. And we should give a shout out to Microsoft too. AKS, the team that works on AKS is the same team that helped build SpinCube. So Microsoft built some of the lowest level pieces of SpinCube. Liquid Reply built some of the operators. SUSE, Fermyon, a whole bunch of us participated together to build this system to run really well inside of heterogeneous Kubernetes environments. So you can run SpinCube in just about any Kubernetes distribution. Rancher actually, SUSE includes it inside of Rancher Desktop, so you've got a nice, easy platform that you can install it, check a checkbox, and you've got SpinCube immediately available to you. So it's just it's been a pleasure to work with lots of different organizations, and now to have all of that inside of CNCF too.
Yeah, and especially what's great about working with all those people is like the passion, right? Everybody's willing to, jump on a call, helping you to basically move the needle to get something out of the door in like a phenomenal short amount of time, right? I mean, we're not talking like, okay, can you simply extend my CLI, right? In the case of, you mentioned Rancher, right? That's like a super popular, like highly adopted container runtime with Kubernetes distribution, and they simply added support for SpinCube within like a matter of days or weeks, right? That was great.
Yeah,
it was awesome. Yeah.
Yeah. And I think that's one thing that is cool about Wasm.io in general, is that that's where you see this sort of cross-domain collaboration in WebAssembly really sort of come to fruition, right? We talked about like there are people there that are showing embedded WebAssembly on robots, I think is one of the things, WebAssembly in the browser, of course, where it started, WebAssembly on the edge, WebAssembly on the server. But all these people are really kind of coming together at Wasm.io because they want to be able to work together, collaborate together, and build a system that really is very robust and very flexible.
Yeah. Yeah, that's definitely right, and yeah, it's so nice to see like all those familiar faces, that keep on pushing the boundaries. But in addition to that, seeing new people coming in. So yesterday there was the traditional, and sorry Matt, the traditional speakers dinner of Wasmeyer, so you missed that as well, and they were like, sorry. Um, And funny thing, it was at the same location where we did the Spin 1.0 release party.
Oh, really? Oh,
Yeah.
wow. Well, that place is
So,
fantastic. Oh, now the FOMO has reached new heights. Oh,
sorry for that. But yeah, I had so many great conversations with speakers that never spoke before publicly about their experiments. Let's say that were with WebAssembly or in the WebAssembly ecosystem, and that's just great to see new people entering
yeah.
the community and getting a space to share their knowledge and to you know make everybody aware of, hey, maybe we haven't considered, or did we consider
Mhm.
that angle? That's interesting, right? So yeah, it's great. It's great to be here. Yeah.
The good thing about, technology, if you find a technology right at the early part of that growth curve and start participating, you can make a tremendously outsized influence in that community, right? And that's, I think, where WebAssembly is it's still at that point where people who are new to the ecosystem, or even relatively new to software development, in a lot of cases, I can think of people who their college projects were tinkering around with WebAssembly and AI, and now this is their full-time job, and they're highly influential in the community because they got in early at the right time. Uh, you know, Collaborated well with others, were dedicated to getting things done, and it's just very cool to see that kind of pattern happen in many different communities, right? It happened in Kubernetes. The people who were involved in Kubernetes early, now run divisions at Google and stuff. The people who were involved in Drupal early, rode this huge wave. And it's true in all of these technology
Yeah.
areas, right? That you can make this outsized influence when you get involved early. And we're still seeing that. I think in WebAssembly, though, I think tomorrow Oracle is going to talk about doing Java and WebAssembly, the last kind of big language. Of course, we're seeing with Microsoft and Akamai and SUSE and other big enterprises adopting WASM and providing it for their customers. I kind of wonder if this year, next year might be the last of this sort of like the early golden era of WebAssembly before really it becomes what we all lovingly call boring technology, right? Where it is solidified, the big decisions have been made. A lot of the stuff that's happening in WASI P3. So P3, WASI has different releases that before it hits 1.0, and so P3 is supposed to be the last feature release of the pre 1.0 releases. So as I understand it, if there's a P4, it'll be merely bug fixes and small tweaks on the things that are there already. And then WASI 1.0 is done. And as is the case with all W3 standards, when something gets the stamp of approval, you're stuck with it for like a decade. So we've got to do it right. But WASI P3 is in the final stages right now. So Luke's talk about asynchronous communication. I think it's easy to think of it in terms of what the paradigm we're already familiar with, right? Oh, so you're talking about threads within a language. The thing that Luke is trying to solve, the thing that the WASI P3 team is trying to solve, is asynchronicity that crosses language barriers. So you can asynchronously call from one component written in, say, JavaScript to another component written in C to another one in Rust, even though those three languages have vastly different views of what parallel computing looks like, what asynchronous computing looks like. The WASI component model is really helping to bridge that so that you can run things and know that even in these kind of highly parallel environments, they will execute correctly. That's a big deal. And that's in the final stages, which means I think we will see the closing of of a chapter here, right? As we kind of finish the first version of WASI, and that becomes sort of the stable foundation for the next, I'm going to predict 10 years, right? I'm going to say WASI 2.0 work starts the day after WASI 1 comes out, but it'll be 10 years before, we see another major iteration of this kind of system interface.
But
that's my
that's
prediction. We can write it down now.
yeah, that isn't that a natural progression, right? Because you have that super, especially for, you mentioned like maybe students or newcomers in our vertical, right, approaching such an emerging technology early, right? Then you have like a steep learning curve, right, with a lot, maybe a lot of frustration on the way to master the technology, because we rely on builds, upstream builds from day to day. It works on Monday, it breaks on Tuesday, and you go down the way, half of Tuesday is gone by hunting down a bug. And I remember I think it was like, right now, 7 years ago, a former coworker of mine, he was like in his early 20s back then, and he explored WebAssembly, right? And he had such a hard time figuring out the tooling, because he was not just approaching that technology from the outside, but also he did not know anybody in that community, right? So there was not that link that you can just ask someone and he points you, oh yeah, use that branch, right, of that tool. And I mean, fast forward a couple of years, there was Spin 0.1 when I stumbled upon Spin and said, oh, this makes it usable for like application developers, for developers that address like business needs. And then it's way easier if you're a little later in that, ramp up of the technology. And
I think, I mean, a good parallel to that is Ruby on Rails, right? Ruby was around a solid 10 plus years before Rails was created. And largely, I mean, it's probably fair to say languished in obscurity, right? It was used here and there, but it was definitely not the language that bubbled up to the top of anybody's radar. And then, Ruby on Rails came along and provided all the right tools to make it easy to build applications with Ruby. And then it exploded. But those people who landed right at the right part of Rails became, again, it's this moment where if you land at the right place, you get an outsized influence over the evolution of the project, over the evolution of the ecosystem from there going forward. 37 Signals, of course, outsized influence. Engine Yard, from which I hail, had outsized influence. I get to work with a number of people who worked on Rails early on and who made these like profound contributions that shaped the entire ecosystem, not just of Rails itself, but of Ruby, of the other pieces and parts in the Ruby ecosystem that gained popularity. Like, was it Chef? Chef, I think, is the one that uses Ruby. And and I think, I mean, to get cut straight to the point, I think the point you're making, Torsten, is that right now is kind of that time for WebAssembly, right? The tooling is turned mature enough that you don't have to read the specification and, hack around in S expressions in order to get things working. But at the same time, we just built a foundation. Now it's time to build the things on top of that.
Yeah, but you're not saying that we are right now the grumpy old mans that know all the how the specs evolved and we know all.
No, this is true. I mean, that age will come, but not yet. It definitely not the point where and it still, I think, is at the point now where you can hold everything in your head, right? Where you can understand how WebAssembly works, how components work, how the different language things work, and have a pretty good idea for how it executes. And I think that was one of the things you were pointing to earlier. Java ecosystem was like that, where early on you could hold the whole ecosystem in your head. And then the tooling got more sophisticated for good and for bad, right? And at some point it became impossible for any one person, not impossible, but very, very difficult for any one person to sort of learn from beginning to end all the pieces of the Java ecosystem. Same with the Rails ecosystem as it evolved. And I think we'll see that at some point in the future with WebAssembly. But right now, it's a good time, right? Really good time to be involved.
Yeah, and I think maybe to bridge the back to what we announced today to Fermyon wasm functions. So Ruby on Rails, for example, I think was the first framework that came up with heavily relying on convention over configuration, right? And we saw like all the other frameworks, ASP.NET, I think MVC was it called in the first place before they rebranded it again. adopted that, and we saw other frameworks adopting that.
Yeah.
And I think we are right now at that point where we, with Fermyon wasm functions, we set like a new default when it comes to like cold start time, when it comes to runtime perf, with latency, latency maybe latency in both directions, right? To the end user, like you mentioned, that blink of an eye, right? That something has to appear there, but also on the other side, like calling an upstream or the origin or origin, so to say, right, is also fast, right? Because we're still in that. We are still on the Akamai's connected cloud, on like that super fast networking layer, and we're still using WebAssembly as the compute layer, or on the compute layer, to ensure that processing or computation is actually fast. And so maybe we defined some of the patterns that hopefully others will replicate at some point in time. Yeah, that would be awesome.
That's, I mean, we should start. I want to see some code. This is a good time to start talking some code at this point, because I think that's right. I think what we're trying to do is build a really good developer experience. What we're trying to do is make configuration very easy. What we're trying to do is give you a really flexible runtime environments that you can select into. It's probably better to show it than talk about it at this point. What do you think? You want to do some Fermyon wasm functions demos?
Yes, let's do that. So sorry for the interception there.
Mirror effect. Yeah.
I just have my MacBook with me. I thought it's don't bring a secondary screen to Wasm.io.
I mean, this part does help me with the FOMO, because doing this kind of thing without 3 monitors does sound.
Yeah. I think I will approach it from a developer's point of view. Right, so we will provide links to technical documentation, and once I'm done with the demo. But at its core, besides Fermyon wasm function as a service, we have a new plugin, or we have created a new plugin for Spin CLI, to ensure that we keep on providing a great developer experience for exploring services or targets like Fermyon wasm functions, and we call that plugin Akka. So we have a Spin Akka plugin right now that gives you like a handful of commands or subcommands that one could execute, again thinking in the boundaries of a Spin application, right? You may want to create a Spin app, and at some point you may want to deploy to Fermyon wasm functions. So that's why we have a deploy command over there. But as you can see already, we can also, navigate Fermyon wasm functions straight from the CLI to basically meet the developer where they are. So as we are today in a preview, there is a registration form, right, to get onboarded. So what you start with once you get access or get invited into the preview, you get like, you can log in. And as an authentication provider, as of today, we have integrated GitHub. So you basically do a Spin Akka login. So let me do that. And that, gives me the, well-known experience of device code authentication flow. So if I click that link, I get redirected to the sign-in page. I sign in with my GitHub account. I granted permission so that the Spin Akka plugin is able to interact with the service on my behalf, right? So I have an account right now in Fermyon wasm functions. I've authenticated and authorized my CLI so that it could interact with the service on my behalf. So what's obvious, let's do a new Spin app. So let's do a Spin new, and let's choose Rust.
Hey, but before you go there, I would have to install the Spin Akka plugin separately from just the straight up Spin download, right? So if I go over to like developer.fermyon.com, I'd be able to click my way in to find there you go, right there.
Yeah, my Git history is the holy grail. I know my terminal history. Sorry. I basically that's the command mentioned in the docs, right? So we distribute the plugin during the preview through a bucket, right? And you can install the plugin on your machine.
So I install that, then I do the login back and forth, and then I can start creating a new app from there. Well, then we're gonna create a new app from there. You can do it in any order you want, but
exactly. Yeah, I thought it would be smart to not focus on like coding actual requirements today. Instead, we simply go do a spin. Oh, come on, spin new over here and say hello, Fermyon -live. Then we go into hello Fermyon. No, not wasm functions in Fermyon live. That's the one I chose. So we end up with, the default spin experience, creating a spin and application manifest. That's the spin toml file we're seeing right now. And besides that, based on your preferences, you end up with an idiomatic Rust project, or crate in that case. In JavaScript, you end up with a package JSON and all those, usual JavaScript bits and pieces. So what's missing right now? So we created a new app, and that app, let me quickly show the librs. It responds with hello world, right? Nothing fancy here, but still we want to explore wasm functions instead of spin. So we do a spin build, which is basically turning our source code into a WebAssembly component. So it pulls down all the Rust crates, compiles it, and we have a spin app that we can simply spin up to run it on local, and we can curl localhost 3000. We get hello world. So how can we take that right now and deploy it? Sorry.
So really, for those of you watching and saying, did we just do anything differently than we would do if we were deploying to Kubernetes or Fermyon Cloud or anywhere else? And the answer is no. This is the same. This is the coolest part about WebAssembly, is the same application. It's going to run in any of those environments. So now we got an app. We're going to go push it into Fermyon wasm functions instead of, say, deploying it into Kubernetes or something like that.
Right. We're just, choosing the home of our app, and in that case we're doing a spin aka deploy. So there are no flags needed for that, because I'm in the folder of my spin application, right? There's the spin toml is in that folder, and if I execute that, what happens right now is, it's pretty, till a certain point, it's pretty similar to what happens when you do like deploy, or you want to deploy to SpinCube, right? We take the WASM file, we take the application manifest, we put that together, create an OCI artifact of that, and then obviously send it to a Fermyon wasm function specific endpoint that is responsible for storing that artifact, right? The artifact, the OCI artifact of my application. And behind the scenes, and this is like, mind-blowing if for people that have done like Azure Functions or AWS Lambda before, we distribute that app across all the regions that in which our service is running, right? So that the app is globally available with close to the user deployments. And we end up with an HTTPS URL. So again, we are integrating with the Akamai products, like a property over here, to have precise routing of requests to that desired workload. So yeah, let's invoke the hello world right now running on Fermyon wasm functions. And obviously we can see this is like super unspectacular besides the runtime performance, right? The end-to-end latency. So we can easily say, let's do a hey, let's say 10
Radu's rubbing off on you. We're going to be doing a load test now.
Sorry.
Load test from the hotel room. Make sure you...
That's why I just do like 10s, right? To show you the distribution, right? And we can see like a fraction of like 3,600 something requests are handled in 0.057, right? That's like phenomenal. And there is
and over hotel
like
Wi-Fi nonetheless.
there's hotel Wi-Fi, and I saw my camera lagging like during the
Oh
screen
yeah,
a few
with
times.
live streamed video. Yeah, that's
Yeah, sorry for that. I think
and I mean I think this is cool because if I were to do the same load test from here, I would use the same URL. Akamai would route me to the nearest edge node to me, and it would execute here, and I would see similarly fast numbers, even though Torsten and I are on the opposite side of the ocean. Because this is what's cool about running inside of Akamai's network. They do all the stuff to make sure that you're hitting the closest available compute instance, and that's and all you as a developer have to do is that one deploy command, and it just automatically happens. That application, in the few seconds you watched it go by there, got deployed out to all of the regions that are in that free tier for you. And even, I mean, I'm the CEO, so I have to say like this, right? Say stuff like this, right? But, if you're looking for particular regions, Fermyon and Akamai can even tool that for your specific regions. So the default pool gets you pretty good global coverage. If you care about regions that we don't cover in that free tier, or you care about just a subset of that and want to make sure everything's only deployed in this particular region, those are all the kinds of things we can do. All right, that's my CEO pitch. Back to the code.
Awesome. No, that was great. You were perfectly setting the stage for the next curl command, because that basically gives us the headers back. And I'm right now close to the Paris, region that where we're running in, right? So that's why my request got routed there. And in your case, you will end up with one of the US regions where we're running the service in.
Yeah, I'm probably Seattle is probably the closest to me.
Yeah. So that's basically invoking the spin app that we just throw over the wall into Fermyon wasm functions. But yeah, as you saw in a spin, when I did like spin akka, there are more commands. So obviously you can always go ahead and do a spin akka list to get spin akka app list to get a list of all your apps or the apps that you have deployed with your account, right? And you can inspect like apps that you have deployed to your account. So I can do a spin akka app info. Oh no, not that one. That one. And as you can see, I deployed that hello Fermyon wasm functions app. I called it 6 times already, and that app is a super simple CRUD API that is basically exposing values and keys, and you can go ahead and create new values at a customizable key. And we, as you as like attendees may be familiar with Fermyon Cloud, there is like a no ops key value store in Fermyon Cloud, and we have the same globally distributed in Fermyon wasm functions as well. And that's basically an example spin app deployed to Fermyon wasm functions to pull and write data from within that fully managed, globally distributed key value store.
And again, this is one of the cool things about the way that WebAssembly works, right? So we have one key value storage library in Spin that you use to read, write, list, delete, all those kinds of things. When you're developing locally and you're using Spin Up to test it, it's provisioning you. I believe it's a SQLite backed database that's just going to run locally. So like nice light embedded database that you can experiment with. If you were to deploy to say Kubernetes, likely it's backed with something like Redis. But again, you don't have to write even a line of config to change, which key value backend you're running. And the cool thing about the Fermyon wasm functions key value storage implementation is that it's this sort of like globally distributed key value storage. And again, you as a developer don't have to do anything at all to reap the rewards of that. It's just that, when you're testing locally, you get a nice local database. When you push it onto Fermyon wasm functions, you're getting that big distributed database to power it.
Yeah, that's 100% correct. And I think it's also worth mentioning that if you want to roll your own key value store, you're happy. You're more than welcome to do that. And you don't have to change the code at all, right? Because we rely on those with interfaces and WASI standards, right? You just have to provide, like, in the simplest form, the connection string, right? To make your app leverage your individual key value store, or if you don't provide any, then it uses our global distributed one.
Yeah. And that interface, that WIT interface, kind of serves as the contract that says we guarantee you will be able to run these operations on whichever of those backends that you bring or that we choose for you or whatnot. And that's, again, one of the things I love about the component model is it makes it possible for everyone in the ecosystem to be able to build applications like this.
Yeah. So in the meantime, I sent a couple of requests to different endpoints of the application, to browse all the keys, to browse or to receive the value at a particular key, to simulate calling or trying to access a non-existing key, and again try to create to read the list of all the keys. That's a way of interacting with your application. However, as a developer, we want to, get some sort of runtime insights. So that's where the spin aka logs command comes into play. So we can basically access the logs that are happening live on the or produced by my workload deployed to Fermyon WASM functions, so that I can get insights on how does my app behave. If I create those log messages, which is as easy as writing to standard out. So that's also possible.
And even if I were hitting this same endpoint again from Colorado instead of from Barcelona, you would see those log entries interleaved here, because again, all that logging data gets aggregated into one place. So again, it's just so cool to run inside of the Akamai network, because we can build very sophisticated backends that you as the developer don't need to know anything about, and just sort of instantly get the kind of behavior that would seem intuitive. Yeah, when I go look at the logs, I'm going to get the logs from every single instance of this application running all over the globe.
Yeah, that's true. So they are aggregated and then made available to me as the, in air quotes, owner of that application, right? No matter where it is instantiated. And so as you said, right, we were working on that, and we weren't allowed to talk about it for months right now, right? And we tried to come up with a reasonable and like a good sized feature set, right? And looking through the subcommands, you may discover tokens which is the last subcommand printed out over here in the help. So obviously, pushing like I did, like doing a spin aka deploy, is a great inner loop experience, right? For me to try out, to get a sense of what does it mean to take my workload onto Fermyon WASM functions and to use it, but in a real world setting, right? We were immediately, also while dogfooding this, we were immediately, okay, how do I CI/CD that? How do I CI/CD that in a secure way, right? So that's why we incorporated like personal access tokens to, allow teams to work together on an app and have the CI basically do the heavy lifting, as in building and deploying the workload whenever we got new features merged into the project. So it comes with engineering in mind, and to address or to support you on your day-to-day tasks.
And I think in the end here, so we've talked about being able to build the same spin application and run it in lots of different places. But there's got to be, there's going to be some workloads you really want to run on the edge. There are going to be some workloads you want to be able to run anywhere, right? And then there's an exciting class of sort of the AI workloads that you want to run wherever there's suitable compute power. So if we were to kind of break it down, right, with Fermyon WASM functions, the first kind of easy thing you could do that you couldn't before is really any of those sorts of edge functions you might have normally done with something like Cloudflare Workers, right? You need to work on CORS headers, super easy because you're going to be able to intercept it way out at the edge, right? Authentication, authorization, gathering edge metrics, managing headers to route traffic upstream. There's that whole class of things that have traditionally been done on the edge that really should be done on the edge. All of those are possible with Fermyon WASM functions. Torsten's actually been writing demos of just dozens of these right now. So we've got tons of demos lined up if you ever want to just drop in our GitHub repo and see those. There's a second class of applications that is sort of recently people have started calling it edge native applications, and I think that's a good way to. We have called it compute continuum applications, but this idea that maybe you don't need to run anything in a data center at all. Maybe the application should run entirely on edge, or maybe the application should run both in a big data center or on-prem and on the edge. And this class of edge native application, actually, Torsten, you just demoed one, right? Running a full-on REST API on the edge, right? Running a full content management system on the edge. That class of applications is also unlocked. And that's the one that we love because we see the continuum from running something locally to pushing something into an AKS cluster to running it on Akamai's edge, even, to be able to run it in embedded far edge devices in the future, that kind of thing. So we're very excited to see that continuum of computing story really play out well. So you got a class of edge functions that are really, you want them on the edge, right? Handling headers, things like that. You got a class of applications that could run anywhere, and maybe you want to run them everywhere. And then the last class is another one that you've been working on a ton, Torsten, are the AI-based applications where you really want to run them. You want to try and balance as close to the user as you can get with also sufficient computing resources, right? Because you don't want to run inferencing when you don't have, say, a decent GPU available or something like that. So very exciting there to see that class of applications. We'll see those more at KubeCon. So, as we're kind of getting to the end here, WASM.io is this week. Over the weekend is Reject in London. And then KubeCon and the pre-days and all the co-located events happens in London next week. We will be there. Akamai will be there as well. We're both going to be showing a lot of these features there. So that's WASM, that's KubeCon next week. The week after that, the second week of April, I think effectively, is the North America Broadcasting Show, NAB. This is a cool conference. It used to be sort of like where the big networks went to buy new satellite dishes and stuff. And it has really morphed sort of into high-end media streaming, AI for media, stuff like that will be out there as well. And then the couple of days after that is Google Cloud Next, also in Las Vegas in the US, and we will be there as well. So all kinds of places where if you're interested in seeing this and you're at one of those shows, please find us, track us down. We'll talk about it with you there. We're just really excited. We started out with the vision for WebAssembly being that we could make use of this write once run anywhere platform. We could build this class of serverless functions that were just really, really fast. And we could, start to run them in surprising places and in surprising configurations. That idea of compute continuum really is that at the end of the day, you can build an application and you can run it wherever that compute is available. And that's what we're excited about. So, so happy that y'all joined us today. I think that after all of the demos and performance tests and video streams, Torsten's hotel Wi-Fi finally croaked and gave up. So we'll be wrapping up here without Torsten. But thank you very much for tuning in today. It has been so much fun to be with y'all, and look forward to chatting with you again soon. And actually, now that I say that, I realized that I don't have permission to stop the video. So we'll wait for a couple of minutes for Torsten to join back up again. I think, again, with things happening at WASM.io this week, there's some really exciting sessions tomorrow. Today, I think, was single track. Tomorrow is 3 tracks. So there will be 2 speaking tracks and 1 workshop track. Like I said, the Oracle research team is going to be talking about Java. That's one I'm particularly passionate about. I like to track language adoption inside of the WebAssembly ecosystem. And so far we've had, something like 22 of the top 25 languages have implemented WebAssembly. There are a couple that just probably never will. CSS is considered a top 25 language. It doesn't make any sense for cascading style sheets to have a WebAssembly compile target. But Java is the one, right? Java is such an important language, has such a huge history. That to be able to see that one running in WebAssembly and running really well in WebAssembly, that's just like, to me, the icing on the cake, the real proof that WebAssembly has really checked off all the major checkboxes. So Torsten, I knew you dropped off the Wi-Fi, so I was just kind of going through other things that were exciting about Wasm.io. I was actually going to end the stream and then realized that I can't end the stream from here. So, but with thank you all.
I was on the stream with my phone, but I had no permissions to promote me to stage, because I was there still, like my ghost was still there. Like, sorry, the entire hotel Wi-Fi went down. It is what it is.
Definitely having nothing to do with your load testing videos streaming.
No.
Just imagine the hotel front desk is like, somebody in here is saturating the.
That happen when you invite the CEO of your company to the stream, right? You drop off the stream and not giving him the permission to basically.
Yep, that's right. You gotta keep me safe from myself. I'm a danger. All right. Well, with that, we probably should wrap up the stream before Torsten loses the hotel Wi-Fi again. So thank you all very much for joining us, and we will see you again next time. Or we'll keep going because I still don't have access to end the stream. I'm trying to think of what other sessions are going on at Wasm.io this week, but I think someone might also be demoing PHP. I was a longtime PHP developer, so exciting to see another language like that come to WebAssembly. And we officially lost Torsten again. So I know what we should do, though. So if you are interested in getting started with Fermyon WASM functions, the easiest thing to do right now is to go to either fermyon.com, or if you really want to dive straight into the technical details, developer.fermyon.com. In both cases, we launched a new version of the website, new version of the developer site this morning, which means you should be able to very easily get in there and start reading about the new documentation, or the new features for Fermyon WASM functions. Again, because we are running inside of the Akamai network, you do need to request access for that, but it's a super easy process. We've been letting in people all morning, so please let us know via the form there if you just want to sign up and get access to that. You'll see all the usual suspects as far as what's supported and what's available. We saw a Rust example this morning, JavaScript, Python, Go, all supported just like they are everywhere else, and similar set of features pretty much everywhere. Where it's different is really in this fact that with one deployment, instead of going to one particular endpoint or one particular Kubernetes cluster, you're getting deployed all over the Akamai network, and you have that easy, seamless, automatic integration with the global presence that Akamai has. Akamai has been fantastic to work with. Again, the coolest thing about the WebAssembly ecosystem right now is that it's still at that burgeoning point, right? And still a huge amount of collaboration across companies, across projects. I think the most ambitious thing WebAssembly ever set out to do, even if you go back to Luke Wagner's original post, is kind of like, we will build a binary format, we will build a runtime, and everybody else will cooperate and bring all these languages and all these ecosystems to play on this. And that has very much happened. Again, that's why Java is so exciting, right? To get support for languages, every language community, every independent language community has to go all in and build the tools to take their programming language and compile it to a WebAssembly binary. We've seen it happen in JavaScript, Python, Ruby, C, C++, all these ecosystems, and now we're looking forward to seeing it at Java. Apparently, the key to getting Torsten back in the room is to talk about Java. So, yeah.
No.
Okay, we should probably end the stream before you disappear again. Thank you all again for joining today. It's been fantastic.
Yeah, thanks. And thanks, Matt, for joining the stream and keeping up the stream while I was away.
Bye.
Bye-bye.